Thank you for those that are coming on. Those that are joining, we'll make a start in around 2 or 3 minutes time. Thank you. Thank you again for those joining on. We'll make a start in around 2 minutes time. Thank you. Thanks again for those joining on. We'll make a start in around a minute's time. I would normally give around 5 minutes for everyone to get on, but we've got quite a lot of content to try and pack into today's session. So we will make a start in about 1 minute's time. And thanks again for all of you, and that being quite a number today that have joined on. Much appreciated. Can you hear me okay, Ben?
Yes. I can hear you. Can you hear me okay?
Can hear you well, I'm with you.
Good. All good?
Good, okay, well I'm going to make a start. There's still a good number that are still coming in, which is excellent. So good morning, good afternoon, and good evening everyone for joining on to today's electrical safety compliance workshop. So it is workshop number 6 out of a series that we've been running since March, and the topic of today is around electrical safety standards and legislation. So also we are mindful that today is it's an important topic, but it's quite a deep topic. So we've worked hard to try and make it as engaging as we possibly can do. And again, we're privileged to have with us today 2 excellent speakers that I will introduce in just a few moments. I thought it'd be interesting just to cover a few fast facts, which I was talking with Ben before the session kicked off to reflect back really on where we've come from since March, when we were in a lockdown COVID-19 situation, and we're thinking, you know, we need to come up with something more creative to enable us to speak with our audience around the world. So we move forward with these workshops, and today we've had over 2,500 people with us. We've issued over 1,000 CPD certificates. We've had an attendance from across 78 different countries, and we've got an average webinar rating of just over 9 out of 10. So I know that there's many on here today that have been regular attendees at our workshops, and the whole Scanware team here want to really warmly thank you for your attendance, but also for spreading the word in these, you may say, complimentary electrical safety workshops that we run, that just have the single mission that we credit you with all being on as well, which is saving lives. So just before we begin, I've managed to get away to an office here today. I think there's probably 3 or 4 people maximum in the head office location I'm calling from. My name is Angus Long. I'm the Global Account Director here at Scanware, but the rest of the speakers are calling in from home. And I know at least one of them has a younger one or younger ones in the house. So the odd banging of doors or clonking in noise, it's a sign of the times. So there is a Q&A box in your Zoom panel at the bottom. And please, any questions, and we warmly welcome questions throughout the duration of the workshop, please put them into the Q&A button, not into the chat box, but into the Q&A button. The reason being is that any questions that we are unable to answer at the end due to time constraints, we'll be having a live Q&A at the end, but any unanswered questions, we will bundle up into a report and circulate that round afterwards. I also repeat, for those that have registered but been unable to attend today, or for those of you that are on the workshop now, but for whatever reason you need to leave throughout the duration of the workshop, you and those that have been unable to attend will all get a full recording of the event and also the Q&A report to go with it. So to kick us off, what I would like to do is just play a brief video to you. It's a 6-minute video of a recent electrical safety incident. Some of you may have seen the video before, but I think it would just help us to have our minds and thoughts focused and aligned for the session. So I'm gonna kick off. Okay, here we go.
I've been an electrician for about 18 years now, and I'm very confident in what I do, and I still ended up in hospital. I've got up that day, a standard day, no thinking anything of it. I says like, I'll bounce in and do that power quality assessment we had to do. I'd assessed the work to be done live, and I was very confident of what had to get done. It was possible to do it live. All I need to do is clip on these 4 crocodile clips, which isn't a hard task, you know what I mean? I can see the buzz bar. I've clipped on the first one, and then I've went to clip on the second one. And as soon as I've touched it, it's just went, just white, yellow flashed, you know what I mean, in my face, and just a really disgusting noise. I wasn't unconscious, but I sort of realised what had happened, and I could just smell it, all my hair burnt, my skin was all burning, and I could see all my clothes were burnt and things, my skin was hanging off and that, and I was just all black.
So when I first found out that he'd had the accident, I was at work, but when I answered the phone, I couldn't actually understand what he was saying. He was all gibberish, but all I got was, I'm in a bad way, I'm being taken to hospital. I just panicked, yeah.
In Mark's case, while he was working in the switchboard, as a result of attempting to pull off 2 pieces of insulation, he exposed the risk of 2 separate electrical phases. In bridging that out with his screwdriver, he's created a large arc flash with high fault current available inside the switchboard, which resulted in a large fireball which burnt Mark considerably.
When I first walked in to see him, he was in a hospital bed and he was just black, and his hair was singed. And
the injuries that I actually sustained would have been, it was actually 12% body burns, so that involved skin grafts. For that to heal, they cut they grind your skin off and then lay that on top of the burns.
so the next day after the skin grafts, as soon as I walked into his room in the burns ward, he was just head to toe in bandages. He looked like a mummy. I think that's when it hit me.
The first week was not an enjoyable time. I was on splints, you know, in full arm splints, leg splints, couldn't even pick my own nose. Every second day I had to get all my dressings took off. So you've got dressings stuck onto skin grafts or sticking to you, so you need to go into a shower and then get all wetted up to release all the stickiness of it, and then take it off, and it just sticks to your skin, and it's sore. I didn't know what I was going to look like. I ended up in hospital for 3 weeks, and off work for 3 months. And what I didn't realise then, due to what I was going through, how it had hurt Mel, how it had emotionally strained her, and mentally and emotionally. It's not a nice feeling to know that the person you love is obviously upset and hurt because of what's happened to you.
Mark definitely didn't realise how much his accident had affected me, a realization of how serious it was. He could have died. Yeah, just had no idea. When Mark started having his rehab, that was hard because he had been in hospital for such a long period of time without moving. He was really happy when he called me that he told me he'd walked for the first time with a Zimmer frame, so he still had to lean on it, but I was really proud.
There's also a big emotional burden that's getting put on your loved ones, whether it be your wife, you know what I mean, your family, your parents, or something like this puts an emotional burden on them.
He loves his work. He loves to be always, keeping his mind active. So when he couldn't go straight back to work, that also held some frustrations and a little bit of anger. I was really happy to see him back at work. I do want to be with him for the rest of my life, so I am grateful that he is healed.
You can prevent arc flash by eliminating the hazard. Turn the power off and isolate the equipment, even if that means rescheduling the work for another time. Remember, working near energised parts can be just as dangerous as performing live work. Arc flash risk isn't just limited to large switchboards. They can also occur in smaller switchboards, electrical supply pillars, and even large electrical equipment. So plan your work and always follow your safe working procedures.
Yeah, I think one thing that I would like to get out there after my accident is just to all the other Sparkies out there, just don't work live. Don't put yourself in situations where, or like I was, just because you're trying to please the client, just because you're trying to get the job done faster. If you've got a wife, kids, family, it's just not worth it. Nothing's worth your life.
Well, as always, it never fails to just freshly impress on me, and I'm sure every one of you that's listening in today, of the reality that electricity has potentially catastrophic effect. And that's why each and every single day, you may say, the mission that we're on, and the speakers with us again today, is to do what we can to save lives. If we can trigger some thought process in someone's mind today, if we can make one change that you can take away, one activity, one action that potentially could save someone's life, and that's a job well done. And so with that, I'm going to hand you over now to Mr. Alan Hajian. So we're really privileged to have him on board with us. He's a former Global EHS Director for the Field Service segment globally within Schneider, with around 15,000 personnel working with him. And he's going to be talking to us, calling in from a beautiful spot in Clearwater Bay, Tampa, Florida. And he's going to be talking to us today, kicking us off around NFPA 70E, which many of you would be familiar with, and talking about how you can have an approach of local compliance, and you can globalize your approach to electrical safety. So with that, I'll hand you over. Just Alan, take it away.
Thank you. So I have we watched the video about Mark, and I have a similar experience with one of our employees. This is the first week I was working with our service organization. We had this in the video. Mark was doing the measurement on the phases, and the accident that our employee was involved in was actually a phase rotation measurement on a bus duct. And as you can see on the picture, it's very the phases are very close to each other, and potential for an arc flash using just the alligator clips. In the video, it was a screwdriver, but here the phases are close enough that the crocodile connectors or alligator clips, as we call them in US, or actually can go cross phases. This bus duct was connected already to the transformer, and there was no breakers or fuses between this point and the bus duct and the transformer. This employee was 43 years old, so a little older than Mark. He was a master electrician. He was had been working for the company for 7 years. He had been a contractor in his own electrical company for 13 years before that, and he had gone through the apprenticeship program before that. So he was very experienced. So this is in late 1999. So when he tried to do the phase rotation, he experienced an arc flash. Unfortunately for him, this arc flash, if you're familiar with how the arc flash is measured, is calories per centimeter square. This arc flash was 160 calories per centimeter square. And it burned the clothing off of him. He climbed down, he was on a ladder, he climbed down the ladder, he laid on the ground, his flesh was on fire. They put the fire out, and he sat up and he said, "I'm burned pretty bad, aren't I?" And they said, "Just lay down and the ambulance is on the way." They took him to the hospital. He was in the hospital for 3 months before he died. He was 43. His wife was pregnant. He had a 5-year-old and a 3-year-old at home. So Mark in the last video was extremely lucky. An arc flash, just as electric shock kills, arc flash kills. So, and that's something that's not always understood by everyone. The area I have in the circle, you can see on the bottom right corner, it's completely evaporated. Imagine the energy that it takes to evaporate 3 kilograms of copper and steel. That is completely gone. And so that kind of energy is available in electrical system. This was a low voltage system. This was a 480 volt bus duct connected 2500 kVA transformer. As you know, a 2500 kVA transformer is used in industry, in shopping malls, it's a very common transformer for electrical distribution. So electricity doesn't discriminate. I don't care where you are in the world, whether in US, in Japan, in Vietnam, in Australia, in India, or France, as long as there is a voltage and current, you have a hazard. And so I was, this was my first week on the job. So I started looking at what had happened, and I started talking to our experienced electrical workers as to how you prevent something like this, and they didn't know. I went to our engineers and they didn't know. So I went to our high powered lab, and an engineering manager, John Gregory, told me that he had been experimenting with arc flash and arc flash consequences and how to measure arc flash for NFPA 70E, and that NFPA 70E was coming out with recommendation for arc flash protection. So the fatality happened in October of 1999, and in October of 1999, the 2000 version of NFPA 70E was published. So it gave me a basis for developing a very robust electrical safety program that could be applied in US, in North America, and globally. So what is the NFPA 70E timeline? So in 1979, Occupational Safety and Health Administration asked NFPA 70E, who was writing the National electrical codes to come up with electrical safe work practices. So they took the 1983 revision and made the US regulations. In 2000, the hazard risk categories and the focus on PPE was published, which I used to develop our electrical safety program. And in 2015, we started moving away from PPE and into safe work practices. And in 2018, NFPA 70E recognized that very experienced employees were getting hurt, and human factor was a big part of that. So who writes the NFPA 70E? So the technical committee is made up of industry, labor, contractors, utility, government, and academia. It's a consensus standard. It's a guidance for saving lives. It's best practices for saving lives and how to comply with regulation if that's your focus. It's not a law or a regulation. It's not adopted into regulation, and it's not enforced by regulators. Regulators have enough laws on the books to enforce whatever they need to enforce. It applies to regular electrical distribution equipment, whether they're AC or DC. Electrical distribution equipment in a factory, in a data center. And what it doesn't apply to is the generating its station itself or the equipment that's under the under the utility directly. And also the shipboard equipment and the distribution equipment for the train. However, in the shipboard equipment and in the equipment under the direction of utility, NFPA 70E has been used very successfully. It's organized in 3 main chapters plus introduction and informative annexes. Chapter 1 is probably the most important one, which covers the electrical safe work practices. The 2018, which is the latest version, has identified the priorities. This is new in 2018. It says use the hierarchy of control and elimination, substitution, engineering controls, awareness, administrative control, and PPE in that order. That's the implementation order. Obviously, the effectiveness is from PPE to elimination. So PPE being least effective and elimination being the most effective. However, when you're working around energized equipment, when you're doing lockout tagout, when you're creating electrically safe condition, when you're doing troubleshooting, awareness, administrative controls, and PPE are paramount to protect the electrical worker. So where do you start? To create a good electrical safety program according to NFPA 70E or best practices. So you have to understand and list the type of electrical equipment in your facility, what tasks are being performed, and which ones are being performed in an energized state. When you have that, you can decide and document what energized work will be allowed, obviously applying the risk assessment and hierarchy of control, and document in which cases energized work is not allowed, and document those work procedures, and then you can train the employees. So when you applying risk assessment and hierarchy of control and deciding what energized work is allowed and not allowed, keep in mind the local regulation. For example, Occupational Safety and Health Administration says in US that all electrical equipment have to be placed in electrically safe condition before you work on or near them. So, and it has some exceptions. So NFPA does too, and we'll talk about those in just a second. So when you write a policy, you want to say, okay, what operations are allowed, limited to operations performed, and what are prohibited. And if they're prohibited, you still have to do the work. You still have to do maintenance, you have to do repairs. So how do you do it? What is the procedure and what is the consequence? So no work without a safe work procedure and no safe work practice shall be bypassed. So those are, that's an example of a policy, very short, 2 paragraphs. So you can use Chapter 1 of NFPA 70E, but you create your own procedure. Chapter 1 has application of work practices, general requirements, how do you create an electrically safe work condition, and requirements for working around electrical hazards. But if you generate your own, if you create your own and make it specific to you, you can be more stringent, you can have more detail, you can be specific, it can be scalable from one factory to 100 factories or from one service to 100 services, and can use for training. So my advice would be to ensure you create your own procedure with your own name. Most of the procedures I've created don't even mention NFPA 70E. They say this is our company's requirement.
Alan, so
Yes.
I think it's an important point that you raised. So NFPA 70, of course, and obviously there's new editions coming out, but largely adopted in North America and a lot of the rest of the world. In Europe, however, we are seeing a very strong influence of NFPA 70 coming in. And I think from picking up, from talking to various clients around Europe, is that it offers a good foundation, doesn't it? As in, it's one of the most descriptive electrical safety guidance documents that there is in the world today, isn't it? And so is that fair enough? As in, it's a good foundation within which to get a feel of how you are to build your own. Is that fair enough?
It is, and also to decide what your policy is going to be, because it clearly indicates what's energized work and what's not energized work. So it's designed to be protective of the person, regardless of where it is in the world. It's not based on a specific equipment. It's based on how much energy is available for various tasks performed on various types of equipment. So whether the explosion happening in Korea or the happening in Mexico, the protection is going to be the same. So one of the most important things to remember that energized work requires justification. Most of the employers leave it up to the electrician, local electrician, to decide whether this work is going to be done energized or not. And that's not the right thing to do. We need to make sure our employers are engaged in why we're doing energized work and how we're doing energized work and what is our justification. It's something that the employer has to stand behind. So for example, in the same policy examples, electrical measurement, testing, and troubleshooting is part of justification for energized work under infeasibility. Installation, repair, maintenance, modification of energized electrical equipment is prohibited because it can be done, or it has to be done, in a de-energized state. So so make sure you understand the justifications and why different some work is allowed in an energized state and some work is not. So the Article 130, it starts with shall be put into electrically safe work condition before an employee performs work. So that's the overriding factor. That is, especially when the employee is within the limited approach boundary or there's a likelihood for increased hazard. So as you look at the tables in 130, a lot of employers I've seen say, go to these tables, figure out what you need to wear, and go to work. And that's not the right thing to do. That's the right thing to do is to identify the work and identify if there is justification for that work. For example, reading a panel meter while operating the meter and switch in equipment in any condition, there is no likelihood of an electrical explosion. But for all the other tasks in table, and I've underlined some of the common tasks I've seen performed in energized state, removal or installation of circuit breaker or switches. That requires employer justification. Why are you doing that in an energized state? Open and hinge covers or removal of bolted covers, insertional removal of buckets, insertional removal of breakers, insertional removal of plug-in devices into busway. I think one of the all of those are energized work with the likelihood of injury to the person performing the work. So the employer needs to justify why it's required. So if you take anything away from this, is making sure you know what the employees are doing and why they're doing it, and whether you take responsibility for that task. The 2021 version comes out the end of this month, if not already available. I gave you links to how to purchase the book, and also the IEEE 1584 book, which is the guidance for performing arc flash hazard calculation. This IEEE is very technical, is not for faint of heart, but the 70 ebooks is easy to use as I went through it. The new version, it just says that the arc resistant equipment has been expanded from just medium voltage or voltages between 600 volts and 15,000 volts to all equipment that meet the arc resistant definition. It recognizes a higher risk for operating a circuit breaker or a switch after the first time installation or maintenance. It adds ISO and IEC references, and it updates the calculation to the new version of the 1584. How do you make this global? Make sure you have your own procedure and it's local and approved by management. Management support is very important. Implement locally and improve it. You can, if you have a small sample size, then you can figure out what can work for you and what can't. Create robust training and qualification around it. Make it easily accessible to everyone. And then you can start exporting it with formal train-the-trainer programs to the believers, right? So you need champions in each new facility that you export this to, each new country. Support countries, entities, and factories in implementation, and track and report to management at the highest level. These incidents can be fatal, and nobody in the company wants a fatality. And therefore, we need to make sure our highest level management is aware of the issues and that they could cause. We were successful in exporting an FPA 70E to India. The pictures from left to right, India, Thailand, China, Italy, UAE, Dubai, and Poland. So you just a sampling of all different cultures, all different areas, and all different types of employees where we exported and implemented an FPA 70E. And I will turn this to Ian.
Thank you, Alan. That's excellent. Ian, over to you. I think you're on mute, Ian. Sorry.
I hope you can all see my screen.
Yeah, we can see it clearly and we can hear you clearly as well.
Very good. Thank you very much. Thank you, Alan. A fascinating insight into the way it's done in America. I always find it interesting to see how other countries do the same thing that we do in the UK, but they approach it differently, but we all have the same aim. So I'm going to talk predominantly about the UK and live and dead working that we use here. And hopefully I'll provide just some points to make you think on. My background is basically I've worked in the utility industry almost all of my life until about 5 years ago, 6 years ago now, where I went to work for a renewables company and created their safety rules, operational procedures, and training packages. And I've personally been trained to work live on both low and high voltage installations up to 33,000 volts. So a quick recap, what's the difference between live versus dead? Well, and low voltage and high voltage. Well, low voltage, generally you need to touch it before you get injured, and high voltage, you generally don't. It has the ability we talk about to jump across air gaps. So they're two really important things to keep in mind. So what is UK legislation? I did a previous webinar where I talked quite a lot about legislation. So I'll cut this down on this one. So the main documentation we have that affects us in the UK is the Health and Safety at Work Regulations 1974, Electricity at Work Regulations 1989, and the Management of the Health and Safety at Work Regulations 1999. But for this, I'm only going to talk predominantly about Electricity at Work Regulations. So there are about 33 regulations in this Act. Predominantly 16 that apply to the things that we're probably, or most of us are going to be involved with. The others cover things like mines, quarries, and vessels. But personally, I know very few, if any, safety rules that only contain 16 rules. So two of the prominent ones out of this regulation are that it requires that work on or near an electrical system shall be carried out in such a manner as not to give rise as far as possible to danger, and that persons must be competent to prevent danger and injury. And we talked about competence in an earlier webinar. So we talked about Mark earlier on and his situation and what happened to him and his decision to work live. And then we talked in the last webinar about unfortunately injury to a guy in Scotland who I understand is making good progress. But this is not a new thing. This one goes back that I've got on here to a company in 2009. You might notice that it took 6 years for the prosecution to take place. And unfortunately on this occasion, the guy died and he'd been allowed to work on live electricity with no training, no supervision, and no appropriate PPE. The company were fined heavily. Fines in the UK have got progressively larger and larger over the last few years, and even leading to the imprisonment of people in responsibility. So it shouldn't be this way. We should be learning and we should be cutting our injuries right down. I mean, this is going on for years, but punishment is not necessarily the answer, it's training. I was talking to Alan earlier on before this webinar, and he was telling me that in India, if someone was killed, they'd probably get a 40,000 rupee payment for their loss. Well, a quick Google check of that comes out at £325, which I guess is a little over $450, Alan? Do you know?
That's right. That's right. Yeah. It actually, it could be between 20,000 to 50,000, depending on how wealthy the family is. The poorer, the cheaper the price.
I find it quite amazing that we can put a price on a human life, let alone one that low. So we talk about legislation and we also talk about guidance. So some of you have probably heard about the IEEE regulations in the UK. When I first worked, they were the 16th and 17th edition. We're now on the 18th edition. And we used to consider them the law that we work to. And although they're called regulations, they're not law, they are just advice. Although compliance with the documentation is likely to allow you to achieve the compliance required under Electricity at Work regulations, which are the law. So we have more guidance, and this is from the Health and Safety Executive in the UK. I find it really good. It's very beneficial, has a lot of information, and is really useful for working live and working dead. And I think we'd all agree that working dead is a safer way of working, particularly when compared to working live. However, there is a need to be rules for both dead and live working. And I suggest that HSG 85 Safe Working Practice is a really good document to have a copy of. And another document that's really useful is HSR 25, which gives guidance on the Electricity at Work regulations. And while it's the view of the Health and Safety Executive and the meanings of the terms in the regulations, I just have to stress that it is only guidance. and only the courts in the UK can provide a binding interpretation. But again, it's really useful. And moving on, there'll be references and things that I bring into this presentation, and they will show you what part of these two documents they come from within the slide. So live and dead accidents, generally caused by people that think it's dead, but it's actually in live. Know it's live, but don't take adequate precautions, or don't have the adequate training to do the work, or appropriate equipment to prevent injury has not been taken. And you can see this comes from HSG 85, electricity at work, and you can find that in there. This is a shot from dead working. It's from HSG 85 again, and it's a lovely little flow chart that shows you a way to get a safe system of work, from identifying the circuit, establishing isolation, proving it dead, down to issuing documents. So dead working. Now this is back to the electricity at work regulations. So these statements are the law as far as we're concerned in the UK, and you can't break them. So they will expect the isolation equipment to be worked on, securing that point of isolation, earthing if appropriate, HV, creating a zone of work, proving dead at the point of work, and it tells you how to do that. Well, the guidance recommends how to do it rather. And then the issue of a written instruction detailing precautions taken or taken. So this is from the guidance notes, and it suggests that an electrical permit to work, that is primarily a statement that a circuit or item equipment has been made safe to work on, i.e. it's been isolated and where appropriately earthed. Now there's another document that covers permit to works issued, and that's HSG 250, and that's a permit to work system. And if you do a permit search within the UK, you will probably come across this document. It is not relevant for electrical working. It's a more general permit to work system, came about following the Piper Alpha disaster many years ago. But it's also and commonly used as a requirement for an electrical permit to be identified. But it is very clear within the guidance notes that that document doesn't apply or shouldn't be applied or suggested shouldn't be applied within the electrical industry. So creation of permits. So what should they say? It should say who the permit's addressed to, the leader of the working party, the exact equipment that's has been made dead, and the precise location of where that equipment is, where the points of isolation are, where conductors are earthed if they're applied, where warning notices are posted and safety locks fitted, what the work is that's to be carried out, the presence of any other source of hazard, and cross-reference to other permits if it's applicable, and anything else that might need to be taken on site, such as putting earths down for induced voltage, for instance. Continuing with the creation of the permit to work, it's suggested that a diagram is preferable on the document, showing the zone of work and where the points of isolation are established. And that permit should be issued by a designated competent person who's been assessed by means of technical knowledge and or experience and is familiar with the system and equipment. And that person should be authorized in writing by the employer to issue safety documents. And then it's strongly recommended that the permit to work is issued at the place of work where the work is being done. I know in some industries they have a permit office where the permit is given out and the work is done, but to my mind, you can't beat showing someone the piece of equipment they're actually to work on while you're issuing the permit to work document. It's recommended that the person who receives the document explains it back to the person that issues it to ensure that they completely understand what's required. I'd take that a stage further. I'd like to see, when I issue a permit, that I issue it to the recipient then explains it back to me so I can check understanding, and make sure that they have got what I want done, and they know where the work is, they know where the point, so safety areas are, they know where the potential energized equipment is. And then I like them to issue that document to their teams. And then I get another check that they're explaining it out to everybody that is working in the area. So we come on to live working. Now, again, there is a lovely flowchart for this that helps to identify where it is, and that's really useful in the book. But we accept in the UK that live working will need to be done. And I'll be very surprised if there isn't anyone who hasn't done live working in the UK. But the regulations say no person should be engaged in any work activity on or near any live conductor where danger may arise, unless it's unreasonable in all the circumstances for it to be dead. It is reasonable in all circumstances for a person to be at work on or near it while it's live, and suitable precautions, including when necessary protective equipment, are taken to prevent injury. That is the law. If you can't meet one of those three, then you can't do it live. No argument. That's the way it is. So what do we see? What's live work? Most people will probably say, don't do live work. Well, in the UK, it's been decided that testing is considered work. And therefore, when you test to prove dead, you're carrying out work. So you're in this catch-22 situation in some ways. You can't issue a safety document because you can't prove it's dead. And you can't prove it dead because it's work, because you haven't issued a safety document. However, the HSE recognise that you still need to do testing. So there's a caveat within the rules that allows testing to take place, just as well, really. And this is the sort of device you'd use for LV, LV voltmeter, or LV tester, with a proving unit to prove the correct function of the equipment. And it's recommended that testing devices are tested before and after testing to confirm they still work. So Regulation 14 allows this testing to take place. And as I said, testing before and after. And although you may be able to justify live testing, it doesn't necessarily follow that you'll be able to justify that the work can be done live. So is it reasonable for the work to be done dead? Oh, yes, there are occasions where it needs to be done. It might be difficult, for example, if not impossible, to commission a complex control cabinet without it being energized, for at least some parts. And then covering up parts that can easily be touched so that they are protected and you don't get injured. Distribution companies, utility companies, as they're often known here, DNOs. To be honest, I worked for those, and we worked on low voltage systems every day of the week, and we had multiple teams working on low voltage systems live, and to be honest, on high voltage systems as well. And that's fairly common throughout the world for utility companies, but their people get very special training. They spend a long time being taught, training how to do it, specialist courses, specialist equipment, and it's very much supervised and controlled. And again, with a railway track, it might not be convenient to turn a railway track off to carry out the work, so they're allowed to work live as well. So what are the dangers from working live? Well, the main ones are inadequate precautions taken for the live work, inadequate precautions to shroud the adjacent exposed metalwork, inadequate precautions to suppress or safely discharge induced voltages or voltages that may be induced after the work has started, and then finally the harm caused to people from reacting to any sort of electrical injury such as a shock, falling down an access ladder, or traumatized. So decide whether it's reasonable to work live. Well, the risk assessment needs to be carried out from managers. and they should decide if it's reasonable. Decisions shouldn't be taken lightly. At this stage, the economic and operational factors should be evaluated against the risk being before making such a decision. The minor inconvenience of arising from working with equipment dead, sometimes arising from commercial and time pressures, very rarely outweighs the risk associated with live work. So, for instance, if you're in a production line and you want something done live, and because you don't want to shut the production line down, is that justifiable when you could do the work either out of hours during the week or at the weekend? It's a decision that has to be made, and in some ways it's a balance, but my personal view is that you should always do dead working whenever you can. So if you are going to do live working, what precautions do you need to take? Well, training and experience is one. Whether the competent person should be accompanied. I was surprised in the video with Mark, who looks to have made a pretty good recovery, that he seemed to have no PPE. There was no one with him. He was wearing gloves. He seemed to have insulated tools, but I'm not sure. The lighting was good. Workspace access, well, it looked good. I can't tell within the cabinet. But additional PPE and visor didn't seem to have any. I was quite shocked at that, but I guess things have moved on and things change. So safety documents for live working, permit to work. Well, should you issue a permit to work? Legally, in this country, there is nothing to stop you. It's not recommended, but it's only guidance. But I would put to you that I think we all understand that a permit to work document is a document that's issued when equipment has been made safe and effectively it's been isolated from all sources of supply, if appropriately earthed, and there is no dangerous voltage left on it. And I think a permit to work is a clear message to that. And because of that reason, you shouldn't be issuing them for live work. People will get confused. And there is a huge amount of risk there. Having said that, I do think that there should be some sort of document that documents that the process has been thought about, the risks have been weighed up, and the decision has been taken to allow live work to proceed. And then that should be documented that that person is given consent to carry out live working. And the issue of a document covers the person that's doing the work, because it lays out what they've been told they can and can't do. But it also protects the company because they are telling the person what they can and can't do. So just to sum up, I talked before about these two documents. They're both HSE guidance notes in the UK, HSG 85, electricity at work, safe working practices, and the electricity at work regulations 1989, which is HSR 25. There are links to both of these documents, and unlike EPA 70, both of these are free downloads from the HSE in the UK. I know they're geared towards the UK, but they're very, very useful books for giving you information and helping you make decisions. So that's it from me. Back to you, Angus.
Thank you, Ian. That's incredible. And I'm somewhat surprised that we've still got some timings left at the end. We're covering an enormous amount of content.
Yeah, I kept an eye on my time. So it's a bit rushed. Sorry, guys.
No, it's good. Anthony, I don't know if you're going to field some of the questions. Just before we kick off, I had a question come in, which has been sent through directly to me, which I thought was an interesting one, was just in regards to signage, electrical safety signage in the UK, I guess probably directing it yourself, Ian. What is the rules and requirements around electrical safety signage on electrical equipment?
It depends a bit where it is. If you're a distribution company or a generator, then you'll have the ESQC regulations. We'll talk about signage around the site and accesses and control of access to it and security. Otherwise, you're looking into General Health and Safety at Work Act, I would imagine, which will talk about having signs to for high voltage rooms that contain electricity, keeping them locked, that sort of thing, I would imagine. But if the question's there, I can have a research for that a bit later as well.
Good, thank you. Anthony?
Yeah, okay. So Alan's obviously been putting some questions in to answer the questions as we've been going through. I don't know if everyone can see these in the audience. So we're just going to touch on one of them, and Alan's obviously already answered this. So the question is, what are the minimum ArcFlash regulations for Canada? And Alan's answer is CSA Z462 is the counterpart NFPA 70E with very minor differences. And then the follow-up to that is, are there any relevant Canadian electrical safety laws as opposed to CSA Z462 standard? And Alan's answer to that is the laws in Canada are per province and there is no federal laws. Most current laws are for shock protection and ArcFlash protection, and methods have not been incorporated. Then moving on from that, then we have another one then. Are there any standards for Japan equivalent to NFPA 70E? And Alan's answer to this one, most countries have 30-year-old regulations which are being updated slowly. USA regulations, for example, have not been updated since 1989. We implemented NFPA 70E in Japan in the data center environment with great success, but called it our policy, procedure, and requirements to work at our company, instead of requirements by external laws, regulations, and standards. So need strong and active operation management to support that. We've had another question from Abdul Majid. It's, are there any standards for GCC to NFPA 70E? If you can just type in the chat box, Abdul, what GCC stands for. I'm not aware of this. I don't think Alan is, unless you've heard of it, Ian, at all.
I haven't, no.
No, so Abdul, if you can pop that what GCC stands for in the chat box, that'll be great. So we can try and answer that for you. Another question that's come in is, how do you justify live working in the UK and would it stand in court? Could you answer that one, Ian?
How do you justify it? Well, if you have a look through the two documents, it does talk about justification and how you do it. And it's basically a balance. If you look at the supply companies, it's a balance of risk of the work to the inconvenience of other people. You may say, well, inconvenience doesn't matter, but when it comes to a utility, it definitely does, because you can't turn off things like hospitals. People get a bit upset if their electric goes off and all the street lights stop working. So it is very much a balancing act in a smaller area like a factory unit. Then I have to say, I think it would be extremely difficult to prove that live working was acceptable other than testing, to be honest, and testing should only be as necessary. But it is all left down in the UK. They talk about the regulations are there. Our regulations don't tell you how to do it, but what they do is they say the emphasis is on the duty holder. That's the person doing the work to make sure that they comply with the law. So the provision is there to work live. Justifying it's a completely different matter.
That's good. Just to kind of going back to one of Abdul's questions here, Abdul's put on obviously, and then Ryan Shook has very kindly added, GCC is Gulf Cooperation Council, a number of Middle East countries. Does that shed any light, Alan, on NFPA 70?
Yeah. Actually, the oil and gas companies that work in the Gulf countries have adopted an FPA 70E, whether that's Chevron, ExxonMobil, or any other U.S. company. Even British Petroleum uses an FPA 70E for protection. So if you're a contractor and you work in that area, you have to comply with an FPA 70E as a matter of course, because you're working for mostly oil and gas companies. If you have your own factory, you can adopt those oil and gas regulations and oil and gas recommendations for protection within a country or within your own factory. So I think we're aligned. What we do with NFPA 70E is aligned with what oil and gas is doing.
That's great. Another one's come in is emphasis is always placed on the hierarchy of controls, but often this is over against PPE being used as a precaution for human factors. This has been the case in some of the recent arc flash and electric shock incidents the last couple of months globally. Could you comment?
Personally, I'm not sure what over against PPE means.
I'm guessing from this that the emphasis is on the hierarchy of controls and kind of eliminating that the control measure of PPE, and just focusing on the elimination, engineering, etc., rather than PPE, and understanding that PPE is kind of a backup in case of human rights. This is how I'm reading the question. So
I think, Anthony, what they're trying to say is that hierarchical controls is often being used rather than using correct PPE, or is being used in reference preferably to PPE.
Yeah.
Whereas I think we would all see that PPE is very much the last line of defense, and all the hierarchical controls in front of that are the ones that should be being met to prevent people being injured. That's my take on it.
I agree with that 100%.
That's great. That's good. And another question has come in. Are there any updates on an NFPA 70E being available in different languages? Alan's answered this, and he's saying NFPA 70E is published in English and Spanish, and CSA Z462 is a Canadian counterpart, which may be available in France, in French, should I say, due to some of the French speaking areas of Canada. Moving on then, NFPA 70E is applicable to plant generation stations. Alan was telling something for the same I couldn't catch. This is from Srinivas. If you can catch that.
The NFPA 70E is not applicable to the generators and the generating station within a power plant. So if whether it's a nuclear, coal, gas, that is outside of NFPA 70E. But all the distribution equipment, all the offices, all the buildings around that support that generating station, NFPA 70E is applicable to. So the generator itself is outside of NFPA 70E because it's a complete different animal than regular distribution of electricity.
Perfect. And then one last question just coming now from Jay. I am new to this training and notice that this training is part 6. How can I view parts 1 and 5? Can you ensure that Jay gets part 1 and 5 to 1 to 5, Ben or Angus?
Yep, can arrange that.
Yep, we'll arrange that for you, Jay. And another one, Benjamin Thompson's asked, what about backup power generators? Alan?
So the backup power generators are included in NFPA 70E. However, they behave slightly differently. And if you have a backup power generator with an automatic transfer switch, you really need to do an arc flash study by a professional engineer to identify the hazards.
Very good.
That's great. That's all the questions answered for today.
So, Ian Burgess, if you could just move on one slide and we'll wrap up. So just for everyone's information, so we have been running now, we had our first dedicated electrical safety compliance workshop to the wind energy sector, I think 4 weeks ago. And we have a series that will soon be launched in the coming, I'd say, days with a subject topic applicable to that industry. And also we'll be running in the end of this month, beginning of November, one dedicated to the data center industry. Furthermore, we've been discussing amongst ourselves the opportunity to have a Q&A session. So we are very conscious that the topics we've covered in the last 6 workshops have been very intense, and we wanted to give our regular attendees, of which I think today we've had registering around nearly 400 applicants, and so there's a lot of questions that are still being unanswered, and so we wanted to give an open forum that focused on Q&A rather than, you may say, the content. So with that, Ian and Alan, thank you very, very much for your attendance today, and for those of you that attended, thank you. Thank you, thank you, thank you. So have a good day. Have a good afternoon. Good evening.
Thank you everyone for joining. Good to see you all.
Thank you. My pleasure.
Thank you.
So I'll give it 3 or 4 minutes, and then I'll close the workshop down.
Would you like for me to continue answering these questions?
Yeah, if there's some questions coming in, we can stick those in for the next 4 or 5 minutes.
Yeah, I see 2 coming in. It says, which choice is better to make in regard to arc flash protection? Class 1, Class 2 under EU or the ATPV, what advice can you give? Under the Class 1 and Class 2 and ATPV, Class 1 in EU references 12 calories per centimeter square, and Class 2 references 20 more than 25 calories per centimeter square. So that's equivalent to ATPV of category 2 and category 4 in NFPA 70E. So they're very similar.
Just to give you an idea, an article with 4 calories protection, ATPV protection, PP article, it would also pass Class 1. So
Right.
The actual arc flash PP protection of Class 1 is the really low protection in terms of ATPV. And to achieve Class 2 in an equivalent article in ATPV, you're looking at 20 cal upwards, generally speaking. I think there's a couple of articles on the market that are quite heavy and stiff that are under 18 cal, I think they are, that meet Class 2. But yeah, Class 1 arc and PPE is quite an easily achieved arc flash test with very low calorie protective equipment. And then category 2 is a big jump. You're talking up to 20 cal difference. Thanks, Alan.
I think Anthony's quick point on that is that you have to be in line with European legislation. Your clothing must be certified to Class 1 or Class 2. It's got to have had the IEC 61482-1-2 closed box arc test. But the recommendation is the two run simultaneously. They run hand in hand. And so you should have, if you're in Europe, you must have a Class 1 or Class 2 standard. But to be able to get an accurate protection level against the risk, you should also have an ATPV calculation on the garments as well. And any organisation that is a manufacturer of arc and flame protected clothing should be able to provide you with that. Alan, do you want to take away this one for
Srini? Yeah, so working in a 450 low voltage compartment control panel and 11 kV circuit breaker, usually if the equipment is built to code, the 415 volt control panel is separate from the 11 kV panel. So when you look at NFPA 70E, it says PPE required for working on control panel voltages greater than 120 volts. And then it gives you a likelihood and a personal protective equipment. So because the compartments are separated, the incident energy is based on the 415 volt, not the 11 kV. A lot of people that do the arc flash studies, they just slap a label on the equipment without separating the compartments. So if you have control circuit compartments that are separate from the high voltage compartment, then you need to make sure you get 2 different labels because they have 2 different hazard levels.
I think it splits at 600 volts on NFPA 70 from memory.
Right. So 600. Right.
I think
so
it changes
this
category
is again,
600
right.
volts.
So this is right. So this is actually control voltage. It's what it's usually run somewhere between 24 volts to 480 volts, but most of the time it's 24 volts. If it's 415 volts, then it requires a category 2 PPE, not category 4. So it really, if we know what the incident energy is, we need to recalculate it for just the compartment if they're separate from the high voltage.
Good. Yeah. ATPV, there is a 50% probability that you will not be injured, or did I interpret that correctly? Yeah, that's right. So the ATPV value is given according to ASTM F959 and also the IEC 61482-1-1 test, where basically it's a 50% probability of the onset of 2nd degree burns. You have to factor into account that when the arc test is done for ATPV, it's an open arc. conductors are 30 centimeters, 12 inches apart. The fabric is then spaced 12 inches, 30 centimeters away from the conductor in 3 separate areas. If you were on the Hugh Hogan webinar, you'd have understood that arc flash is very, very directive in where it goes. So in an open arc, it can go anywhere. So they test the samples on those 3 swatches around the arc itself, and then they carry that out over 7 times. So you end up with 21 sampled evaluations, and that will then give you look at the break open, look at the arc threshold achieved, where it comes under the stall curve, where it goes over the stall curve, and then give you that 50% probability. When you factor that into PPE, you've then also got to think of you're not always going to be guaranteed to be standing 30 centimeters or 12 inches away from the actual incident. You could be closer, you could be further away. Air gaps are a difference. They add a difference to the actual fabric performance and how much heat passes through the garment. So it gives it a 50%. There is a new standard called ELIM available in Europe, which gives you the actual elimination of a burn injury. However, the elimination is only any good if you're stood greater than 30 centimeters away from the actual switchgear itself, which while the 50% is probably the best option because you can't always guarantee and prescribe the exact working conditions of any particular equipment. Hope that helps you. Question?
Very comprehensive. I think we need to respect the time frames. So thank you very much, each and every one that's still on. I'm afraid we're gonna have to shut the workshop down now, and you'll have the recording sent to you within the coming days. And again, Ian and Alan, thank you very, very much for being on the Saving Lives journey. Goodbye all, and I'm closing the webinar now.
Thank you.
Thank you.
Yeah, cheers.